Now our goal is to convert this differential equation into a linear system of differential equation, but this time is a third order. What's going to happen with third order? Is the method going to change? Well, let's see. I would start by rewriting this. Let's rewrite this into standard form. So we want to have the highest order derivative on the left-hand side and everything else on the right-hand side. So let's have, I'm going to move the y first. So I'm going to add y to both sides of the equation, subtract 10y prime to both sides of the equation, subtract 6y double prime to both sides of the equation, and then don't forget that t squared that we still have. Now, what I'm going to do is I'm going to make some definitions. I'll say, hey, let's say that I'll call y x sub 1. And I'll call y prime x sub 2. And you guessed it, I'll call y double prime x sub 3. Now, I'm going to take the derivative of these. So I'll take the derivatives. And what are we going to get? Well, let's see. Y prime is equal to x sub 1 prime, which is really equal to, well, we have y prime here. So that's equal to x sub 2. Okay. And now we're going to take the derivative of that second definition. So we get what? Y double prime is equal to x sub 2 prime. Well, what's that equal? Y double prime is also equal to x sub 3. Okay, looks like an interesting game. Well, let's look about, if I take the derivative of this, what am I going to get? I'm going to get y triple prime. And what is y triple prime? Well, we have it up here. So what we're going to do, though, instead of writing it with respect to y, we're going to write it with the definitions that we made. So y is equal to x sub 1. So I'll write x sub 1 here. Then we have minus 10. And what was y prime? Well, that's x sub 2. Okay. And what was y double prime? Well, that is x sub 3. And then don't forget that lonely t squared. Okay, now it's not lonely anymore. Now, look at what we have. We have the derivative on the left-hand side and a variable that relates to that derivative on the right-hand side. And except for this one, I forgot to put that this is also equal to x sub 3. So let me write that over here. X sub 3 prime is equal to all of this because we were taking the derivative of this and we were writing it over here. Okay, that looks nice. Let's see if we can write this in matrix form. Well, if I were to align all of them, I would have x1 prime is equal to 0x1 plus 1x2 plus 0x3. What about x sub 2 prime? X sub 2 prime, well, that's 0x sub 1 plus 0x sub 2 plus 1x sub 3. And finally, we have the last one here. X sub 3 prime is equal to 1x sub 1 minus 10 x sub 2 minus 6 x sub 3, and we also have the t squared. Oh, that's cool, because now we can rewrite this in matrix form. And it's almost there already. We can write x sub 1 prime, x sub 2 prime, x sub 3 prime, prime time. And then here we have 0, 1, and 0, 0, 0, and 1. And then we have 1, negative 10, and negative 6. See, I can do this because I lined them up properly. So I can pull out the coefficient matrix with ease. And now we have x sub 1, x sub 2, and x sub 3. We close that, and then we add another vector, 0, 0, and t squared. Okay, let's close that. And that's our system. And again, I would define this to be the x vector derivative. I would define this to be my A matrix, this to be my x vector, and this to be my forcing function. So I could rewrite this whole thing as x prime equals A times x plus f of t. And that is useful because now I realize, hey, this is not a homogeneous. I'll have to use some methods to solve the particular, which I'll show you how to do in a second. All right, I hope this was useful, and I'll see you next time.